Hello to everyone. In this lesson, we are going to learn about the general solution of a differential equation. And specifically, we are going to look at how to find your general solution when you are given the differential equation. So one might say, what is the general solution? It is the first thing to note, it is a formula that gives all solutions of a differential equation. That's all the general solution is. It's a formula that gives all solutions of a differential equation. What do I mean by that? Another name we use for it is called, it is a family of solutions, because it contains arbitrary constants. So it contains arbitrary constants. So let's say I write something like y is equal to c x1 plus b x2. So c and my b are my arbitrary constants. Okay, so it means different values of c and b are going to give me different solutions. So that gives us the name of a family of solutions. So now let's look at how we can find our general solution when we have a differential equation. One example is we have the second derivative of y with respect to x being equal to 4. This is just a basic differential equation of order 2 and degree 1. So the first thing we do is integrate both sides. We can choose to integrate both sides. I integrate. So we are doing everything with respect to x. So integrating the square y, the x squared with respect to x is going to give me what? It's going to give me dy dx being equal to 4x plus c1. Because when we integrate this, we have to add what? A constant to it. The next thing, we still have dy dx, so we are going to integrate again. So we have to integrate this again with respect to x. So we are going to end up with y being equal to what? 2x squared. Please, if your integration is weak, I will advise you to revise on that, because here will become what? Let me slow down. For this lesson, let me just show you. So we have 4x squared over 2, and that gives us 2x squared. And here, since this is a constant, when we integrate with respect to x, we get c1x. And because we are integrating an indefinite integral, we add another constant, which is c2. So in the long run, our general solution becomes 2. Let me write this well. Our general solution becomes 2x squared plus c1x plus c2, where c1 and c2 are my arbitrary constants. Okay, so that's how we solve it. And sometimes we can be asked to show whether a given equation is a general solution of a differential equation. So here in this example, I have phi equal to c1 cos x plus c2 sin x. And we are asked to show whether it's a solution of the square y the x squared plus y equal to 0. So what we do is we are going to find, we are going to find because this here is in the second order, we have to find our first and second derivative and substitute it into this equation here in order to check whether it will be equal to 0. And if it becomes 0, it means this here is the solution to this differential equation. So we are going to assume that phi is y. Okay. So the first derivative. So let me say phi prime. I think that one, or let me use the other notation. Phi dx. So differentiating cos, we get what? Negative c1 sine x plus differentiating sine x, we get cos x. So we get c2 cos x. But we are looking for the second derivative. So we have to differentiate again. So this time it is the square phi over the x square. So we end up with what? Negative c1 cos x, and differentiating cos x, we get minus c2 sine x. So you can notice that we said phi is this. So wherever we see y, we are going to substitute it for y, for phi. And wherever we see the square y, the x square, we substitute it for the square phi over the x square. So in the long run, let me use another color. In the long run, we are going to have something like this. The first one is negative c1 cos x minus c2 sine x, and it's added to our y. So this is what I've just written here, and it is added to our y. Our y was, because of space, let me write it beneath it. So we have c1 cos x plus c2 sine x. So we have to make sure that it evaluates to what? It evaluates to 0. If it evaluates to 0, it means this is the solution. So let's cross check it and see. We have negative c1 cos x. We have c1 cos x. So it means they can what? Cancel out. We have negative c2 sine x and we have c2 sine x. This also will cancel out. It means this will evaluate to 0. So therefore, we state that therefore, let me use the symbol. We say therefore phi is a solution to the differential equation. So that'll be all for this lesson. I hope you understood it, and you can comment any question you have for me. Thank you. Bye bye.